So free fall. If gravity is the only force acting on an object, we say the object is in free fall. It is a bit misleading because people think the word fall means moving down. Actually, when an object is on its way up, it's still in free fall. It is still accelerating down at negative 9.8 meters per second squared. That bugs kids, but hopefully we spent enough time looking at it this year that I've convinced you that that is the case. On the way up, there is no problem with an object having a positive velocity, but still accelerating downwards. Now, to bring in, Joel, some vector notation, especially when we launch projectiles sideways as well as up, we're going to call that negative 9.8 AY, vertical acceleration, because we're going to talk about vertical and horizontal components. Example 1 says, fill in the following key facts about projectiles. You should know this already, but let's just confirm. The launch is V initial, and you know what? Let's put a number there, Chris, just to make it nice. Let's say our V initial is 12 meters per second. We'll do it both algebraically and with numbers so that whichever way you feel more comfortable with, we can wrap our brain around this. At the top, what's V? Oh, by the way, what we're doing here is we're standing on the edge of a cliff and we're launching it straight up from the edge of a cliff. At the top, what's V? For a split second, it comes to a stop. What's V when it gets even with the launch? When it comes back to the same height as it started from, how fast is it traveling? Good. Negative 12 meters. You know what I'm going to write? Negative VI, or for our example, negative 12 meters per second. And what's T? Well, algebraically, we would use this. Remember that bad boy? VF equals VI plus AT. But we would get the T by itself. How would I get the T by itself? Abe, how will I get the T by it? I'm going to get the T by itself. I want to move this over first. How will I move this over? What's it doing to the T? Adding, subtracting, multiplying, or dividing? So how will I move the VI over? And then what's the A doing to the T? Adding, subtracting, multiplying, or dividing? So how will I move it over? Told you. Nice. Are you saying this, Abe? The VF would stay where it was. You would minus a VI to that side. You would divide by an A, except instead of putting the T here, I put it in front because we're like that. But for what it's worth, in our little example here, it's actually, since V final is negative VI, specifically when you're coming back to the same height that you started from, the time is negative 2 VI divided by the acceleration, negative 9.8. In fact, as a nerd, when I'm standing in line in an amusement park ride somewhere, if that ride has a free fall component and I'm curious to try and figure out either the speeds or the time of, I can just double the initial velocity, and instead of dividing by 9.8, what's a nice number that's very close to 9.8 that I can do math with in my head? Yeah, I just divide by 10, for what it's worth. What's its displacement? Trick question. What? I heard it. Zero. Why? Because displacement is change in position. How high was it when it was launched? Cliff height. How high is it right now? Cliff height. What's its change in position? Nothing. What's nothing as a number? Zero. What's the displacement just before impact? If I call this h for height, careful, what's the displacement just before impact? I'll give you a hint, it's not h.
Negative h.
Why negative? Because we ended up below where we started from. If we start our stopwatch on the cliff, then that becomes our new zero, our de facto zero height. So this would be negative h. Those were some of the key ideas about launching a projectile vertically. And that is always going to be true. When we launch something sideways or at an angle, what we're going to do is we're going to break that motion up into vertical and horizontal, listen to the word, components. Yeah, we're going to use the vector stuff in the next unit as well. And we're going to say vertically, this is what's going on. At the top, it's going 0. Acceleration is negative 9.8. T equals whatever. Displacement, if I'm ending it below from where I started from, is negative. And we're going to treat this other part of the motion as a horizontal. We'll analyze that later. Example 2. A projectile is thrown up and leaves the thrower's hand at 10 meters per second. A, how long does it take to reach the top of its trajectory? B, what is the maximum height that it reaches? This is great review for our final exam because this is when we started out, we used an acronym, I called it DFIC, which really stood for list your data, find a formula, insert the numbers, crunch the numbers, and get an answer. So listing my data, first of all, what are they asking me to find in part A? TJ, what are they asking me to find in part A? So what is how long out of the variables in physics that we've been using all year? Folks, what's how long? Chris, what's how long? Time. Nice. I thought you were dozing on me. Nice recovery. So I write down T equals question mark because I've just written something down. TJ, I feel better. It's no longer blank. Right? Always write that down. Identify what they're asking me to find. I write it and I put a question mark next to it. That also tells me what I'm looking for later on. I'm probably looking for an equation that better have T in it. Yes? What else do I know? What's that 10 of velocity because it's meters per second? Yeah, which one? Ah. Right, Chris? What else do I know? What's VF? Because in this case, they're talking about going to the very top. What else do I know? This I never need to tell you anymore. It's understood if you're in free fall. Acceleration is negative 9.8. So I'm looking for an equation that has T, VI, VF, and A in it. Which one? Get the T by itself. You should say that with authority. T equals VF minus VI all over A. All over A? Right, we've been, by the way, and I know some of you are still struggling with the formula manipulation. That's okay. But hopefully most of you have wrapped your brain around it enough that you're recognizing this is a great shortcut. It cuts down on my memorization. I've gotten good at it. Oh, it even helps me figure out how stuff fits together better. Yeah. Okay, Vaughn, what's V final? 0 minus, what's V initial? Divided by negative 9.8. And this is nice. I'm going to get a negative divided by a negative. Positive time. You know what? This is going to be 10 divided by 9.8. This is almost 10 divided by 10. It's going to be like 1.01 or 1.02 or 1.03 or something. What do you get? It's going to be really close to 1. I can tell you that. 1.02 seconds? Matt, what's B asking me to find? Except height isn't a variable that we have in our equations. What have we usually called, what letter have we traditionally used for height? We've used H occasionally in our energy section. But what's it really? Anyone? D, yeah. Technically, it's a displacement. If I had turned the page, or if the situation had changed, Joel, I would relist my data, because like if they had been talking about on the ground or at a different time, but we're still talking about the top, and I defected in the previous question, so I'm going to use that. I'm looking for an equation. It has to have a D in it, and then it should have a VI, a VF, an A, and I guess it can have a T. Which one? There's only 2 equations, I think, that have D's in them, right? Or is there 3? No, there's 3 equations that you guys have that have D's in them. One doesn't have an A, so that's gone. Jake?
VF squared equals VI squared plus 2AD.
Now, I have two options. I can use VF squared equals VI squared plus 2AD, get the D by itself. In some ways, Jake, I like that because I'm not using T. There is another equation that has the D by itself, Jake. Which one? D equals
D equals 1/2.
VI. That one. D equals...
D equals VIT plus 1/2.
That one, you know what? I'm going to use that one because we're nearly done Physics 11. I'm going to have enough confidence that I can actually calculate time correctly. So, you know what? I think we're good enough in Physics 11 now. Let's trust that time is right. And Jacob, I'm going to use actually good old D equals VIT plus 1/2 AT squared. Because that lets me straight plug and chug. In fact, you know what? If I had time, I'd do it both ways on the test. And if I get the same answer both ways, then I have to be right. And I know my time answer for A must have been right because I couldn't have fluked into getting the same answer both ways. VI was 10 times 1.02 plus 0.5 negative 9.8 times 1.02 squared. How high will this go? Get your head up, my friend. Yeah, you.
You possibly scroll for a second.
Nope. I'll bring it later. Relax. You haven't missed anything hugely crucial. It's stuff you know already. What do you get? Don't try and catch it. Just pick up Cole with where we are. Trust me, it'll make more sense. Yeah, like small, like 5 point something, what? 5.1. Barely higher than the ceiling. Well, you know what? 10 meters per second, not that fast a toss. This is basically somebody going with their hand. So, is it 5.1? 5.1 meters. Okay. Chris, that should all have been almost boring review. We did that in November. In fact, you did some of that in Science 10. Let's up the ante a little bit. Turn the page. Let's launch from a cliff. I will ask, any of you stood on the edge of a cliff and thrown rocks over? As long as there was nothing harmful down below? Fraser Canyon's very nice for that because the Fraser River is down below, so you can't really hurt a river, right? My nephews could do that for hours. It's a great way to stretch your legs. A projectile is thrown straight up at 35 meters per second off of a 70-meter high cliff. You know what? Let's gulp. Cliff. And I guess the projectile is doing that. Where this is 70 meters. Yeah, I'm not going to put VI on my diagram. You could put VI equals 35 or whatever. That's fine. Enzo, what are they asking me to find in part A?
Time to talk.
No, let's write T equals, question mark. Time to what? Okay, what do we know?
VI equals 35.
VI equals 35. AY equals negative 9.8. We're going to start to use some vector some vector notation, because that way when we launch at an angle, we can distinguish between the vertical accelerations and vertical and horizontal components and what's going on.
VF 0.
Oh yeah, at the top VF is 0. By the way, also remember in the kinematics section, Maddie, anytime you wanted to find one thing, you needed 3 things to find the fourth, because every equation in that unit had 4 variables to find so 3 to find the fourth. Help me out. I need an equation that has T, VI, A, and VF in it. Joel, which equation has T, VI, A, and VF in it, my friend? Can you get the T? Can you get the T by itself in your head? Music, magic, milk and honey. Joel, what's VF? That's why we take the, it's, by the way, can you see, it's worth taking the time to list the data because it takes 1 second and it sure cuts down on your thinking, yes? 0 minus, what's VI? What if instead of launching it upwards, what if we had launched it downwards? What would VI be?
Oh, it'd be 35. Well,
Yeah.
it'd be negative 35.
Negative 35. Yeah, but if I had launched it downwards, I would just call VI negative, yes? But this is a positive 35. What's A, Joel? Did you say negative 9.8? Okay. How many numbers on top? Hey, let's remember how our calculators work. 2 numbers on top, brackets around the top. Yes? And conveniently, I get a negative divided by negative, which is a positive, because I do here and want the positive time. You get 3.57 seconds, yeah? 3.6 seconds, I'd take that too, but we'll be a little accurate. Did I leave you guys the whole half page to work on? Yes? Okay, got lots of room. Good, 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 good. B. B. Jordan, what did they ask me to find in B? Oh, let's write D equals question mark. Distance to where? Okay, what do I know about the top? What do I, let's list my data. What do I know? Sure, Jordan, what do I know? VF is 0. What else? VI is 35. What else? Now, I could use T time. We did use T time here. Let's try the other approach, because Jake suggested the other approach that we could use is we could have said A is negative 9.8. He said there is actually an equation that has those 4. It's the squared one, yes? Let's, just for practice, because we're towards the end of the year, let's use that one and get the D by itself. So VF squared equals VI squared plus 2AD. How would I get the D by itself there? Well, there's a VI squared. What's it doing to the D? Adding, so how will I move it over? So you're going to have a VF squared already. You're going to subtract a VI squared from it. Now, the other thing I notice in front of the D is a 2A. What are those doing to the D? So how do I move them over? Divide. It's going to be 0 squared minus 35 squared all over 2 times negative 9.8. Again, remember on your calculator, brackets around the top, brackets around the bottom. 0 squared. I guess, Enzo, 0 squared is just 0. I didn't really need to put the squared there. I could have just put a 0. Well, whatever. Minus 35 squared, close bracket, divided by bracket, 2 times negative 9.8. And again, remember, even though to multiply, I tend to write brackets. I tend to write a bracket like that. I tend to type a times sign. It's clearer on my calculator. What do you get? Chris, what'd you get? Even? Oh yeah, holy smoke, that's a fluke. Usually that means Mr. Kamosi made this question up to make it work out evenly. Actually, I made this question up and I just fluked into a nice answer. 62.5 meters. C. Taylor, what's C asking me to find? Didn't we just find that? Isn't it 62.5? Or did we?
No, that's the distance.
Add 70.
What?
Add 70.
Ah, we just found the height above the cliff. Is the cliff the ground? No? Okay, so you know what? How about we use H for height? In fact, how about this? H total. That'll be really clear to us later on. Took all of 1 second to write. You're saying it's going to be 70 plus 62.5. Heck, I think I can do that in my head. 132.5, yes?
Yep.
So relative to the ground, this projectile reaches a maximum height of 132.5. D. Jamie, what's D asking me to find? Time, T equals question mark. From where to where? Okay, so that's the situation we're looking at. From the top, that's going to be initial. To the bottom, that's going to be final. What do I know? VI, because we're starting at the top now. VI is 0.
D is 132.5.
D is not 132.5. What? Why negative? Because if we're starting at the top, are we ending up above or below from where we started? Ah, and good, you'll never do that on the test now that you did it here, yes?
Couldn't it just be consistent?
Pardon me?
Couldn't it just be consistent in everything?
No, you'll see why in a second. What else do I know? I know one more thing that's screamingly obvious.
VF is 0.
VF is 0. You're saying that as you fall, right before you hit the ground, you come to a stop and don't hit the ground? By the way, V final after impact is 0, but that's a whole different situation. In fact, that's a whole different acceleration. The ground is now decelerating you. It's not negative 9.8. That's where we get the saying, it's not the fall that kills you, it's the landing, right? What's the acceleration? I'm still in free fall. So I'm looking for an equation that has T, VI, D, and A in it. Can you spot it, TJ? It's got to have a T in it, so that I think eliminates one of them. It's got look for an A because only a few of them have. Oh, actually, look for a D and a VI and an A and a T. Which one? Which one are we talking about, folks? D equals VIT. Let's write that down. D equals VIT plus 1/2 AT squared. And this equation for this situation does have one nice feature. What? Do you see it? Because VI is 0, that's going to vanish. Now, if that wasn't true, and you're trying to find T, don't write this down, but look up, Greg. Don't write this down, but look up. What's that exponent there?
Squared.
If this VIT doesn't cancel, then this is an equation with a squared. This is actually and the only way you can find T is to go negative B plus or minus the square root of B squared minus 4AC. You're near the end of your grade 11 math. How many of you have seen that equation now that finally this year? So physics 12, we will no longer set up every question so that VI is 0. We'll say, hey, let's give you an initial velocity this time. And we'll say solving a quadratic is fair game. Having said that, some of you that haven't cheaped out, some of you that have listened to my rant about getting a good calculator, you might have a built-in quadratic solver on your calculator, and I let my kids use it in Physics 12. I say to them, all you need to do is write down the quadratic equation, and if you go straight to your calculator, how do I know that you didn't use the quadratic equation? I have to assume that you did use the quadratic equation, that you didn't use technology. And then there's those of you that cheaped out for $3 less, and you'll be frustrated next year. This year, however, Chris, VI is 0. By the way, also the reason I show you that, hey, holy smokes, quadratic formula actually useful in real life if you're looking at projectiles. Yes, totally. How often can we say that in math? Not as often as we'd like. So I think if that cancels, really I have this. D equals AT squared over 2. Hey, Mr. Dueck, what happened to the 1/2? What did happen to the 1/2? How did I choose to write it instead? Yeah, timesing by half, same as dividing by 2, but that looks cleaner. That looks cleaner. Greg, what are we trying to find? T? How would I get the t by itself? What's the a doing to the t mathematically? Adding, subtracting, multiplying, or dividing? Multiplying, so how will I move it over? What's that 2 on the bottom doing to the t? Adding, subtracting, multiplying, or dividing? How will I move it over? So if I hear you correctly, and I think I do, you're saying the d stays where it is. You're going to times it by a 2. You're going to divide it by an a. Now, Greg, that would give you t squared. How do I get rid of a squared? Were you and I doing this in your homework or something the other day after school one? This seems very familiar. No? Was it you? I almost feel like I had this conversation. Okay. Now we're plug and chug. And this goes back to Cole's earlier question. He said, hey, Mr. Dueck, do you really need that negative there? The reason you do is if you don't put that negative in for the displacement, you do have a negative in for your acceleration. You'd end up with a negative square root, and your calculator can't take a negative square root. Here, now, it would tell you, by the way, there is a built-in error check, because if you left the negative off and you tried typing it in and hit square root, your calculator would give you a math error, and you'd say, I've done something wrong. Nature is saying, hey, you haven't given me the correct data. Two times negative 132.5 divided by negative 9.8 equals square root of that. Do you get almost exactly 5.2? Yeah. 5.2000 seconds. Can you put it face down on the appropriate block, please, for me, kiddo? E. E. Janai, what's E asking me to find? Did we just find that? No? Oh, we found time from top to bottom. How can I find total flight time? How can I find T total? Oh, okay, so there are quicker ways to do this in one fell swoop, but they're not way, way quicker. Usually if they give me launching off of a cliff and they want me to figure out how long it takes to get to the bottom, I'll just find time to top, because I've been doing that since November. Then I'll find time to bottom from the top, because I've been doing that since November, and I'll add them up. You can get there in one fell swoop using the quadratic formula, like I just pointed out, because that's when VI is not 0. If you haven't got a quadratic solver, it'll be just as quick to break it up into chunks. What's the total time? 5.2 plus 3.57. 8.77 seconds. Coming back to you, remembering this? We've been kind of using this all year long anyhow, but next page, example 4. Enzo, could you stand up and stand right in the middle here? And stand right here facing Matt, so facing that way. Example 4 says this. A person bends their knees 20 centimeters and flies 50 centimeters into the air and flies 50 centimeters into the air. Okay. We'll imagine he flew 50 centimeters into the air. Well, let's try it one more time. 50 is, well, half the meter stick, right? So watch to see the speed get there. Go ahead. You know what we used to call that? Basketball days, we used to call it a phone book vertical. Because if you put a phone book down, he would struggle to jump over. Anyways, okay. Have a seat, Enzo. But that's what we're talking about. And I hope what you saw, Chris, is there's actually two things going on. Straightening the knees and then free fall after leaving the ground. Two separate situations. A says, determine the speed when they leave the ground. What are they asking me to find in part A? V. Yeah, which one? Final or initial? Initial? Final? The answer is yes. You're both right. It's going to depend on whether you're looking at while his knees were straightening, because if you look at that situation, then V final is what he reaches when he straightens his legs out. Or if you're looking at when he leaves the ground, because when he leaves the ground, I know V final. What's V final after he leaves the ground? 0 for a split second, in which case it would be V initial. Which one's correct? You know what? It's going to depend which one we know 3 things to find for. So the first thing I'm going to do is I'm going to write down part A. I'm going to try the V final approach first. By the way, the V final approach is going to be incorrect. I'm doing it on purpose, though, to show you, if you guessed wrong, how you can, with a minimum amount of work, fix your guess and not have to rewrite a bunch of stuff. So I would say, well, maybe they're asking me to find V final. Well, V initial was 0 because you started out before we straightened your knees out at rest. What else do I know? Sorry? A? What's the acceleration? Once he leaves the ground, I know A. Once he's in free fall, what's the acceleration? Negative 9.8. But while he's straightening his knees, in fact, you know what? I think while he's straightening his knees, the acceleration must be bigger than 9.8, because if I do a free body diagram and go winner minus loser, he better have a bigger force than gravity. Otherwise, he can't possibly leave the ground. Yeah, I know. He barely did, and so clear. But okay. Using our imagination here, trying to really... who's got the best hops on the basketball team right now?
Sam last year, and then Sanj this year.
Sanj?
Yeah.
Hakeem? No, I used him this morning, and it was to weep. You know what? Sadly, the answer really is no one. No. So back to here. You know, I do know this. But I don't know anything else. And what I said to you is I need 3 things to find the 4th. So if I had said I'll try looking first of all at the ground situation, I'm wrong. Then I would say, you know what? Let's try looking at the air situation, which means I'm not finding V final. What am I finding? This is how you can fix it really easily. Oh, and what's 0 after you leave the ground? Not your initial velocity, but your final. Oh, and what's the displacement that they gave me while you're in the air? 0.5, because, right, got to go to meters. Oh, and while you're in the air, I do know that. So even if you start out incorrectly, did that on purpose, James, pretty minimal fix. Scribble a little bit, still organized. Hey, I'm looking for an equation that has VI, VF, D, and A in it. VI, oh, okay. Get the VI by itself, because that's what they're asking me to find.
VF squared.
It equals VF squared minus the 2AD. Now that would get you VI squared. How do I get rid of a squared? The square root of that whole sucker, right? Is that okay, Abe? Yep, yep. Plug and chug. VF, 0 squared minus 2 negative 9.8 0.5. I think the 2 and the 0.5 cancel, and I think the minus cancel. I think you just get 9.8. Let me try this. Because 0 squared, I don't even need to, I'll type it, but 0 squared, that's just 0. Minus 2 times negative 9.8 times 0.5. I think you just get 9, yeah, square root of 9.8. Kind of nice. 3.13. So, if Enzo could get his 0.5 half a meter vertical, to do that, he would have to leave at 3.13 meters per second. If, yeah. TJ, what's B asking me to find?
Their acceleration.
Oh, acceleration. A equals question mark. It's still during the push, so we're still on the ground. You know what? Let's list what we know on the ground, because situation A was in the air. So I'm going to re-defic. What do I know about on the ground? Ah. What was VI? 0. What was VF? Cliff, what?
3.13 meters.
3. Oh yeah, VF when he left the ground is V initial. Sorry, VF after he straightens up is V initial as he leaves the ground. You know what? Those are the same values. Does that make sense, Nick?
Sure.
No? Okay, it's okay. Pause the video for a second.
Distance would be point.
D. The distance that we are accelerating for is, yeah, 0.2. Oh, and by the way, Enzo, I can tell you, it better be bigger than 9.8. Otherwise, there's no way you could have left the ground. Right? If it's less than 9.8, you get this. There. I did accelerate up. Yes, you saw me. But not enough to leave the ground. That's what you do every time you stand up out of a chair. You give yourself a small acceleration, not bigger than 9.8. If you do leave the ground, you had to have been bigger than 9.8. Negative 9.8, but bigger than 9.8. Hey, what equation has A, VI, VF, and D in it? Oh, VF squared? Get the A by itself.
VF minus VI.
No.
Oh, VF squared.
Squared.
Minus VI squared. All over 2D.
Yes. Squareds don't suddenly magically vanish. By the way, common mistake kids make. In fact, I remember on this test, some kids magically made up an equation with no squareds. No. VF, 3.13 squared minus VI, 0 squared, all over 2 times 0.2. By the way, D, positive or negative? Is it positive 0.2 or negative 0.2? Because you're heading up. Sure. I'm actually not going to use 3.13. I'm going to use this decimal value that I have stored on my calculator. So I'm going to go bracket answer squared minus 0 squared. Again, I didn't really need to put the squared, but I will. Divided by bracket 2 times 0.2. Oh, nice. 24.5 units. Meters per second squared. C. What's C asking me to find? Oh, the hang time? Oh, the hang time. So not how long it took Enzo to straighten his knees, but once he left the ground, if he had hit 0.5 meters, how long he would have been in the air for had that been the case. So I still know in the air A is negative 9.8. I know at the top V final was 0. V initial leaving the ground was 3.13. I think that's enough. How can I calculate this? T equals VF minus VI over A. 0 minus 3.13.
Do you need to have can you do this equation with the distance too?
Probably. D equals VIT plus a half AT squared. That one? Yeah. So you'd have T equals the square root of 2 times D divided by A? Sure. What do you get? Point 0.32? Why is that wrong? Why is that not as hang time? That's only going up. He also has to come down. So really, we should double this. His hang time should have been a little over half a second. There is a famous playground New York basketball player, a legend, named Herman Helicopter Knowings, and there's all sorts of stories about him. There are stories saying that one time he dunked the ball twice before hitting the ground. There are sayings that one time when he was bored, he jumped up and grabbed the top of the backboard. And there is a saying, they claim that he got called for 3 in the key while hovering above the key. So here's the question. If that story is true, how high would Herman have to jump for this to be a true story? means 3 seconds in the square region by the basketball rim. In other words, how high would he have to jump to be in the air for 3 whole seconds? You want, you know VF is 0. You know A equals negative 9.8. And you want time to be 1.5 because you want it to be on the way up. Because 3 in the key means on the way up and on the way down, so I'll just look at on the way up. Have I got an equation that has V final, A, T, and D in it? Nope. Nope. So what you'll need to do is find V initial using VF equals VI plus AT, then D equals VIT, and you'll find that this has to be an apocryphal story. This has to be a fake story. This has to be a embellished legend. It's up to you to try. I'm not going to walk through it all the way because it's been a long lesson. You guys are getting a little fidgety. I'm going to pass on example 5. Yep.
I was just wondering why the time was
3 seconds is top and bottom. Have a seat. Have a seat. You can be okay? Okay. Because I let V final be 0, that meant I'm talking about final being at the top. If it's 3 seconds up and down, then it's 1.5 seconds on the way up. Is that all right? I won't give you one quite that tricky, although the nerd within me is like, hey, let's disprove the physics. If you're bored sometime, a couple of years ago, Kobe Bryant did a commercial where he jumped over a thing of snakes and cars and things. Someone has done a wonderful physics analysis of that, and it's clearly computer generated. I'm sorry, but it is. Sorry, what was your question?
So is this helicopter guy a real person?
These were old playground legends in New York back in the 50s and 60s. I heard somebody talk about Earl Manigault. He's also a big one as well. He died a couple of years ago, and he also was like 5'11" with crazy hops. And there are all sorts of stories about him. Kareem claimed that Abdul-Jabbar claimed that he was the best player he'd ever played against, and that kind of a thing. And there is a good movie about it that you can watch sometime.
I'm pretty sure Kobe Bryant's in the world record for jumping in a car.
No.
Somebody is.
Oh, there are people that have done it. In fact, just recently somebody did it again. But in terms of high jumping, the world record high jumpers are the guys in the Olympics because it's all technique. What's your homework for this? Now, this is also to work on tomorrow if you want to. Here's what I think I skipped 4, 9, and 11. So let's try that. 1, 2, 3, skip 4, 5, 6, 7, 8, skip 9, 10, skip 11. Oh, I think I assigned 12, which is just a conceptual one. This is a good review of free fall. This is going to lead into the next unit. But this you can work on next week if you want to as well. Tuesday is going to be going over take-home quiz number 2 that I'm giving you tomorrow. Unless you're away tomorrow, then you're also going to get it today. Thursday is your test, so you have plenty of time to work on this stuff.